Washington, May 3. The first building blocks of life on the Earth may have formed thanks to eruptions from the Sun, finds a new study. The study, published in the journal Life, revealed a series of chemical experiments over the years by various scientists that show how solar particles, colliding with gases in the Earth's early atmosphere, can form amino acids and carboxylic acids, the basic building blocks of proteins and organic life. The experiments suggest that an active young sun could have catalyzed the precursors of life more easily, and perhaps earlier, than previously assumed. In the late 1800s, scientists speculated about the origins of life to have begun in a warm little pond, a soup of chemicals, energized by lightning, heat, and other energy sources, that could mix together in concentrated amounts to form organic molecules. In 1953, Stanley Miller of the University of Chicago tried to recreate these primordial conditions in the lab. He found that 20 different amino acids had formed. From the basic components of early Earth's atmosphere, you can synthesize these complex organic molecules, said Vladimir Eruptions, a stellar astrophysicist at NASA's Goddard Space Flight Center in Greenbelt, Maryland, and co-author of the new paper. But the last 70 years have complicated this interpretation. Scientists now believe ammonia, New Hampshire 3, and methane, CH4, were far less abundant. Instead, Earth's air was filled with carbon dioxide, CO2, and molecular nitrogen, N2, which require more energy to down. These gases can still yield amino acids, but in greatly reduced quantities. Seeking alternative energy sources, some scientists pointed to shock waves from incoming meteors. Others cited solar ultraviolet radiation. Eruptions, using data from NASA's Kepler mission, pointed to a new idea: energetic particles from our Sun. In 2016, Eruptions published a study suggesting that during the Earth's first 100 million years, the Sun was about 30% dimmer. But solar superflares, powerful eruptions we only see once every 100 years or so today, would have erupted once every 3 to 10 days. These superflares launch near light-speed particles that would regularly collide with our atmosphere, kickstarting chemical reactions. After publishing, Eruptions was contacted by researchers from Yokohama National University in Japan, where Dr. Kobayashi, a professor of chemistry, was trying to understand how galactic cosmic rays, incoming particles from outside our solar system, could have affected early Earth's atmosphere. Together with Kobayashi, Eruptions created a mixture of gases matching early Earth's atmosphere as we understand it today. They combined carbon dioxide, molecular nitrogen, water, and a variable amount of methane. The methane proportion in Earth's early atmosphere is uncertain but thought to be low. They shot the gas mixtures with protons, simulating solar particles, or ignited them with spark discharges, simulating lightning, replicating the University of Chicago experiment. They found that as long as the methane proportion was over 0.5%, the mixtures shot by protons, solar particles, produced detectable amounts of amino acids and carboxylic acids. But the spark discharges, lightning, required about a 15% methane concentration before any amino acids formed at all. And even at 15% methane, the production rate of the amino acids by lightning is 1,000,000 times less than by protons. Eruptions added, protons also tended to produce more carboxylic acids, a precursor of amino acids, than those ignited by spark discharges. Thank you for watching. Please subscribe to channel and click on bell for more daily videos.